All right, I hope I should make sure to include this in the announcements, which is in my future and your past. I hope you're not doing all of these videos at the same time because it is a long section. Okay, but we're in the last part. We're talking about compressing and stretching, both horizontally and vertically. All right, and this is really the most challenging part of the section for many, many people. All right, and this is going to have to do with multiplication. All right, so let's go back to our good friend Desmos. And if we're looking at a function, let's say we're looking at the square root of x, and I wanted to stretch that up vertically. That's essentially multiplying all the outputs. If I take the square root of x and multiply it by 2, everything on this white graph is double what it is on the green graph. So for example, double 0 is 0. All right. Over here we are at 1, 1. If we stretch that graph, it should double that y value. And it is. Got the point 1, 2 up here. 4, 2, 4, 4. All the y values over here are doubled. We are stretching out that y graph vertically. Again, vertical on the outside, multiplying it by a 2 on the outside. And similarly, right, if I wanted to squish the graph, if I wanted to compress it, I could multiply the outside by 1/2. Now all the y values on the outside have been squished in half. Okay? The vertical stretching is multiplying on the outside, vertical, by a bigger number. Compression by a smaller fraction. Okay? And that's going to be, in case you were getting a little lonely, that's going to be the next addition to our table. All right, so you can be friends with the table again. So vertical stretch by A and vertical compression are going to be our next two by A. So it's sort of the same thing, right? Either way, it's multiplying on the outside of this function, multiplying on the outside of this function. Just here, A is going to be bigger than 1, and here A is going to be between 0 and 1. So compression by a half, right, is a half down here. Half is between 0 and 1. If it's negative, then you have compression or stretching and a reflection. Okay, so an example of a vertical stretch could be something like y is equal to 2 times 1 over x, which as a side note, a lot of times it's written as 2 over x. These are the same thing. 2 times 1 over x, combine those fractions is 2 divided by 1. So as a side note, watch out for this. All right, and a compression vertical compression could look something like y is equal to 1/3 times the cubed root of x. Takes that cubed root function, compresses it vertically by 1/3. Okay, vertical because it's on the outside. And that leads us to the last transformations, the one everybody hates because they always get it flipped. And that's horizontal compression and stretching. So you might think, well, okay, multiply by a 2 on the outside, stretches it vertically by 2, so multiplying on the inside should stretch it horizontally by 2, right? Well, let's see what happens. Look at another function again. Ooh, in there. Go back to our good old friend, the parabola, the quadratic. We multiply this on the outside by 2, it vertically stretches it. What if we multiply it on the inside by 2? What happens to the white graph? We have the green graph, and to get the white graph, we just squished it. So you might think that this horizontally stretches it again by 2, but if it's on the inside, it's not a stretch anymore, it's a compression. And if we actually wanted to horizontally stretch it, we'd have to multiply by a fraction. Horizontally stretching it like this is a fraction on the inside right here. See that 1/2 on the inside. So again, if something's on the inside, it kind of works backwards from what you might expect. This went all the way back to our first video, right? You might think, oh, subtracting moves it to the left. But again, notice the The white graph got moved 2 units to the right. Things kind of work backwards from what we think when it's on the inside, which was the two things that we could sort of summarize the section with. The inside of the function means horizontal stuff, but it also kind of works sort of backwards. So anyway, if we have a horizontal, finish off that table, I barely have enough room. Stretch or compression by A, it's going to be on the inside again. So f of AX for both of them. The difference is that a stretch has to have a fraction, and a compression is going to be a bigger number. Okay, so a horizontal stretch could look something like y equals 1/2 x squared. Barely running in, we're kind of running out of room here. I do apologize. And a compression could be something like 2x squared. Horizontally compresses and stretching it. Really watch out for these ones, okay, because they'll get you. All right, so another really big thing that causes issues in this, once you combine all of these transformations together, all 10 of those things in that table, is the order on which you apply things kind of matters. So let's talk about that really quick. Order of these is going to matter. So your first step is going to be horizontal shifts, almost always. There are some fringe cases. Whenever you can, shift it left to right first. Your last step is going to be a vertical shift. And don't worry, I know where I'm going with this. I'm trying to save you a little bit of writing and a little bit of thought. First is always going to be horizontal. Last is always going to be vertical shift. And in the middle, it's just everything else. So really the only thing that matters is that you do horizontal shifts first and vertical shifts last. Okay? If we have a bunch of things together, go back to this. Okay? So let's do some examples. We got some good ones. In video 3, I forgot what number we were on, so I said we were on letter F, which means that now we're on, this is not a 6, by the way. This is a G. G as in gosh, golly, I love this section. All right. So, describe the transformations. There's going to be a couple things going on, and we're going to make sure that we go in the right order. Part A is going to be g of x is some function f, but now of 2x. So here's the logic. Again, most important thing of logic is if you're not taking notes, which I understand because I go kind of fast, you might not want to pause every 5 seconds. Even if you're not taking notes, write this table down and make sure you give yourself enough room. Okay? This is the downside of filling things in as you go. All right? Use this table for reference. So what do we have? We have multiplication on the inside. Each of those words corresponds to something. Multiplication, that corresponds to something. Inside, that corresponds to something. Anytime in this whole section, anytime you have a transformation on the inside of a function, inside these parentheses, that's going to correspond to something horizontal. Multiplication corresponds to stretching or compressing. So combining these two things, we know we have a horizontal stretch or a horizontal compression. And remember, if it's on the inside, it's sort of backwards from what you might think. You might think doubling it stretches it. But it's on the inside, so it goes the other way. This is going to compress it. Okay? This is a horizontal compression by 1/2 or by 2. I'll accept both phrasings, even though there are some semantics that we can get into on why that's not okay. I'll accept both. Horizontal compression by 2 or 1/2. I'll take either answer. That's all there is to part A. Identifying the function transformation. Do another one. Part B. G of x is equal to 2 times f of 1/3 x. So again, there's two things happening here. No pun intended. We have multiplication on the outside. Oh, multiplication, stretching or compressing. We also have multiplication on the inside. Again, just like before, stretching and compressing is what multiplication is going to be doing for us in this section. On the outside, that has to do with vertical stuff. Inside, that has to do with horizontal stuff. So multiplying by 2 on the outside. Vertical, stretching or compressing. Vertical stretch by 2. One-third on the inside. Horizontal, stretching or compressing. Also stretching. A horizontal stretch by 3 is usually how we phrase this. Okay. And that's our answer here. Okay. Utilize your table. Do it step by step. Identify what's going on in your problem. All right. G of x equals 5 times x plus 3 squared minus 2. Oh my goodness. There's a lot going on here. 5 is being multiplied on the outside. It's a vertical stretch. Vertical because outside. Stretch or compression because multiplication. And we know it's actually a stretch because it's a number bigger than 1. This section is dense. Okay, you have to do a lot of problems. Rewatch the video maybe. Do some extra problems. Ask me if you get stuck, okay? Then we also have plus 3 on the inside. That's left 3. Minus 2 on the outside. That's down 2. Make sure we get our order right. Let's start with a horizontal shift. Let's end with a vertical shift. Do everything else in the middle. So horizontal shift. It's on the inside. It moves at left 3 units. The last thing we're doing is the vertical shift. That's down 2 units. And everything else goes in the middle. Well, in this case, there only is one other thing. Multiplying by 5 on the outside is a vertical stretch by 5. All right. Do another one. Part D. Example G, part D. Yes, excellent numbering system. K of x equals negative 3 times the square root of x minus 1. Again, the order matters here. Here, the order really matters, just like the last one. We start with horizontal stretch. Horizontal shift. Start with horizontal shift, end with vertical shift, everything else in the middle. So we start with horizontal shift. There is no horizontal shift. We're not adding or subtracting anything on the inside. There's no horizontal shift. We're going to end with that vertical shift. At the very end, we're going to say this is down 1 unit. Now, everything else goes in this middle region. We have a negative on the outside. Outside means vertical. Negative means reflection. It's going to be a vertical reflection. And I'm okay with you saying vertical reflection. But again, technically it is reflection about the x-axis. Because again, right, the x-axis looks like this. If you reflect something about that axis, it's a vertical change. We also have multiplying by 3 on the outside. The fact that that 3 is on the outside means vertical. And it's either a stretch or a compression. Since this is bigger than 1, it's going to be a stretch. All right, let's do the last example, 2 parts. We just did letter G. Now it's, I guess, example H. Find a formula for part A. Y equals the square root of x reflected about the x-axis and horizontally stretched by 2. We do things one at a time to make sure we do it in the right order. We're always told to start with horizontal shift and with vertical shift. Well, in this case, we don't have a horizontal shift or a vertical shift, so the order is not going to matter for us here. We only have a reflection and stretching. So first things first, let's reflect this about the x-axis. Again, reflecting about the x-axis, that's a vertical change. Vertical means outside. That's our first step. Incorporating this thing. Next, we have to horizontally stretch it by 2. Horizontal means it's going to happen on the inside. Stretching means multiplication. And remember, since it's on the inside, it's going to work kind of backwards from what you might think. So instead of multiplying by 2, we're going to divide by 2 or multiply by 1/2. This horizontally stretches it by 2. Let's check our answer. Right? What we have is that the square root of x, we said that if we have the negative square root of x, we said that's reflecting about the x-axis. Were we right? Yeah, that's what happens if you reflected about the axis. Well, what happens if you then, after that, horizontally stretch it by 2? Well, we said that this is what happens when you horizontally stretch it by 2. Is this horizontally stretching it by 2? It's kind of hard to see. The white graph into the blue graph. Well, we're right here. Stretching it by 2 horizontally means we should double those x's. Same y coordinate, double the x. We're right here. Horizontal stretching means we should stretch x coordinate. Same y coordinate, and the x is doubled, 8. Okay, so the white graph did get stretched to the blue graph as we wanted. That's just a way to sort of visualize what we're doing right here. That's our answer. Let's do part B. The last thing in the whole section. Thank you for surviving. I'd be very sad if I got a report, hey, one of your students died because they were watching your video and it was that awful. I'd be very sad for multiple reasons. Okay, let's say we have y equals 1/x. Vertically stretched by 2. Right 4. And up 2. 3 things. We do it one at a time. So this will be our first thing, and then we'll do our second thing, and then we'll do our third thing. I don't think so. The order is going to matter, remember. We always start with horizontal shifts. That's going to be our first thing. We always end with vertical shifts. That's going to be our last thing. And everything else is in the middle. Make sure you get your order right. Go back to what we said at the beginning of this video. Horizontal shift is first, vertical shift is last. Everything else is in the middle. So here we go. First step, we need to move it right 4 units. That's on the inside. Right is subtraction. It's backwards from what you might think. 1 minus 4. That's our first step. Next, we need to vertically stretch it by 2. Vertically means outside. 2 stretch means multiplication. And because it's on the outside, it is multiplied by 2, just exactly like we might think. As a side note, a lot of times we do simplify this. Again, this is 2, same as 2/1. You can combine these. 2 times 1 is 2. 1 times the denominator is like this. You may see either case. I'm okay with either case. Just a heads up. And finally, we have to move it up 2. So at the very end of this is our third step. We take the same thing we have and we add a 2 at the very end. And that's what we get. And that's 3.5. All right. A long section. Okay. I will try to remember to tell you guys to start early because it will kill you if you try to do this all at once. And again, we don't want that. If you have questions, let me know. Otherwise, good luck with the homework.